Welcome everyone to our ATA educational webinar. Thank you guys for joining. Today's topic is comparing Simcenter 3D with Femap for mechanical simulation. My name is Mason Wu. I am the business development engineer from ATA Engineering. I am based off in our San Diego headquarters, and I'm very happy to be joined by John Coulter from Siemens, who is a subject matter expert of the Siemens simulation products. So he'll be the one presenting the Simcenter 3D versus Femap. Before we dive into the actual content, there are some housekeeping notes. All attendees will be muted throughout the webinar. If you have any questions, feel free to type them into the chat or the Q&A panel section, and we'll have John answer them at the end of the presentation. You'll be able to ask him directly if you like. You can put that into the chat, and we'll unmute you at the end. This webinar will be recorded and will be available on our website and on the ATA YouTube channel later on. Okay, before I hand this to John, I just want to give a quick overview of ATA Engineering, who we are, and how we might be able to support your team. So most people recognize ATA as an engineering service company. That's about like 80% of what we do. And we'll talk about the remaining 20% in a bit. Our core founders has been together for over 40 years, and we have vast experience providing high-value engineering services, focusing on test and analysis-driven design. Majority of our work is in the defense and aerospace industry. That's about like 70% of what we do. However, we also work on other industries, as you can see here. About who we are an employee-owned small business with a full-time staff, around 200 people. Most of them have advanced engineering degree, as you can see on the right. We have 9 regional offices across the US, and as I've mentioned before, we have years and years of experience focusing on design, analysis, and tests. This includes everything from structure design, structural dynamics, CFD, thermal, fiber acoustics, and more. Testing-wise, we are the leading independent model testing group in the US. We have a lot of experience flying our team to the test article location and conduct ground vibration testing and use that data to help drive the model design. All right, so we have talked about the 80% of the ATA service business. And aside from that, this is the remaining 20%. This is how most of you joining the webinar today know about ATA Engineering. So we are a Siemens VAR, value-added reseller, who not only sells the product, but also provides software support and training to our customers. We really excel in products and solutions that we use and primarily on design, analysis, and tests. For example, you have NX for CAD, Star CCM Plus, Femap, Simcenter 3D for simulation. And testing-wise, we are one of the Siemens partner in the US that can provide Simcenter testing hardware and software. And just very recently, ATA was awarded the Partner of the Year in North America by Siemens, showcasing our dedication to support our customers. I feel like what sets ATA apart from other Siemens resellers is that because we sell what we use, our customer appreciate our familiarity of these tools. And it shows in our hotline support. Whenever you call our support hotline, you are speaking with an actual ATA project engineer who uses the software every single day, doing engineering problems and understand it right away and can do a screen share with you to resolve those quickly. Additionally, we teach a variety of classes, primarily dealing with simulation. And we actually generate all the Siemens training material for the Nastran software. So a lot of times when you go up online to the Siemens website, try to find a Nastran course, you will see the location being either in Denver or San Diego, because that's where the 2 locations of ATA Engineering, and we'll be the one teaching it. All right, so this is an interesting slide. This slide showcasing the ATA and Siemens partnership over the years. So it started with a company called SDRC back in 1967, which SDRC developed a popular PLM tool called Ideas. And at the time, ATA was part of SDRC, with ATA stands for the Advanced Test and Analysis Division. And in 2000, we spun off from SBRC and became ATA Engineering, continually focusing on the delivering high-value engineering services and testing support to our customers. And after a series of acquisition, SBRC was eventually acquired by Siemens, and the popular IDEAS software was integrated with Unigraphics and later on became the well-known NX product line. In 2007, because we use so many of the Siemens tools, we love the Siemens tool, Siemens asked if we were interested in becoming a Siemens partner to help support customers who needs assistance. We accepted it and became Siemens VAR. In 2016, our VAR business grew rapidly. We achieved the Gold Partner status, and around that time, Siemens acquired CD Adapco, which is the company behind the famous CFD tool called Star CCM Plus. And because we use and love Star so much, in 2018, we became one of the Siemens partner to sell and support Star, also achieving platinum status at the time. And in 2021, we became the first partner authorized to sell and support Siemens test and measuring hardware and software. And fast forwarding to today, we are working on providing more training and free resources for our customers. And just like this webinar, we hope you enjoy what we're doing. All right. Last slide before I hand it to John, just want to encourage people to visit the ATA website. We have lots and lots of free resources, Femap APIs, white papers that you will be able to download. It also has our hotline support information, which is one of the unique advantage getting your Siemens software support from ATA. All right, with that being said, I want to introduce today's speaker, John Coulter. He's a subject matter expert in engineering and simulation solutions, over 30 years of experience. He has worked with leading companies such as PDA Engineering, MSC, ANSYS, and for the past decade, he has been with Siemens as part of the global business development team. He helps customer align priorities, craft simulation and testing results, and will be presenting what's the difference between Simcenter 3D and Femap today. So take it away, John.
So like Mason said, the topic today is kind of comparing Simcenter 3D and Simcenter Femap for mechanical simulation, really as part of a digital thread strategy. As we're working with more and more customers moving forward, it's kind of the ultimate goal is to be able to have all of their products, captured in some type of a digital thread, and we'll explain going forward, what our vision for that is and how we help customers to do that. But that's the context for today's presentation. This is me. If you want to connect with me on LinkedIn, I am part of the global business development team here at Siemens, primarily looking after Simcenter Mechanical simulation tools. And we're part of the Siemens Digital Industries software. So just to give you a little bit of the agenda that we're going to cover as we move forward, we're going to start off with just a slight discussion about, product design and what an engineering digital thread kind of looks like and what's kind of driving where Siemens is going these days. And then we're going to jump into Simcenter 3D and Femap, contrast the two somewhat, explain what they are, how they're similar, how they're different, and really why we have two different products, and then a little bit about how we bundle them now and sell them. And then we'll have a little bit of a discussion on simulation process and data management and why that's important to the digital thread. And then we'll open it up for questions and hopefully answers. So if we look at just a typical product design and engineering digital thread, this is the process that we start from conceptual design, going through product design and engineering, verification and certification, production, and then into deploy and sustain. And there are many different parts as you move your way through this digital thread. But if you look at the product design and engineering portion of that, there are several things that fall out there. And depending on what your particular workflow, yours may be similar to this, have some parts, and it may not have some parts, but this is kind of a generic product design, engineering, digital thread as we envision it. And so there's a lot of things on there: system simulation, software design, electronics design. But the two that I want to kind of focus on for today's discussion is mechanical and structures systems design, and then analyzing and simulating in that context. And that's the two areas where most of the mechanical design, is done in this engineering digital thread. So let's look at those a little bit closer. So if we look at the mechanical structures and system design portion, you can, in a typical workflow, kind of center this right in the product design portion. And, you're dealing with things like your preliminary inputs are defining your structures and mechanical systems interfaces. You're looking at your weight distribution. You're defining the distribution of the system topology. And then in the more detailed design, you're looking at assemblies and detailed components. You're tracking weights and performance targets, those type things. And you get your inputs from product and certification requirements, the product architecture, system simulation models that you may have produced, prior to the design. And then outputs are typically, as you can see there, design parts and assemblies, and define, manage product configurations, those type things. And there are other threads that are kind of connected in there, but we're going to focus, kind of on what I've talked about there. And then if you look at the analyze and simulate, where that comes in, looks a little bit different, but it's still in the product design. And, we're looking at executing a loads analysis, executing analysis and system simulations to confirm the design assumptions that were made and to validate the interfaces, optimizing part designs, resolving any technical issues through virtual testing and simulation. And then a lot of companies, will go from there into physical testing and correlate those models back. But you can see the inputs and the outputs there as we look at that portion of the digital thread as well. So if you look at the Siemens products, especially in our mechanical portfolio, we have two different products that kind of cover the whole breadth of the simulation that goes on within those portions of the digital thread. So we have Simcenter 3D and we have Simcenter Femap. And one of the questions that I get often, and the reason for today's webinar, is, well, wait a minute, you got two different products here. They look to me like maybe they do the same thing. How are they alike? How are they different? Which one might best suit my needs, moving forward? So that warrants a little bit deeper discussion, and that's what we're going to try to do today. So, but, together they cover the breadth of most of the customers' mechanical design, simulation, and verification workflows. They are kind of targeted at maybe two different parts of the workflow, or maybe even two different types of users, and we'll get into that as we move forward. So we have Simcenter 3D to start with. This is our integrated multidiscipline simulation environment. It's used to predict mechanical performance across a lot of different physical domains, and it has a very comprehensive set of geometry-based integrated CAD and CAE solutions all together in one environment. And when we contrast that, we have Simcenter Femap. It's been around for about 40 years now. And, it's all about creating, editing, importing, and reusing mesh-centric finite element models of complex products or systems. And we'll look at each one of these a little bit more in detail. So let's start with Simcenter 3D. So if we look at Simcenter 3D, if you look at it at the very top level, it is an integrated multidiscipline simulation where we try to answer things like, does the simulation require full CAD associativity? If it does, then you'll see as we move forward, this is probably an ideal environment for you, because that's what we have within this tool. We have both CAD tools and simulation tools together. But it answers questions like, how long is a part going to last? Is it going to be noisy? Is it going to get too hot? Is it the right, is the motor size right for the loads? can it be controlled effectively? If it's, a 3D printing design, or, will it print in the right shape once it's been designed, those types of things. And so it is our, like I said, our comprehensive geometry-based integrated multi-discipline CAE solution. It is linked to 1D and 3D co-simulation. Of course, it's linked to data management, which of course Femap is as well. We'll see in a few minutes. But it's also linked to our test and CAE correlation. Like I said, as part of the digital thread, a lot of our customers, have to validate their designs through physical testing. That's one of the expertise areas for ATA, and they know all about it, and they're a great partner. But, that's all about looking at your simulation model and correlating the results with what you're seeing on the test side, and then figuring out if they're different, why they're different, or, hopefully they're the same and they correlate well. So in the Simcenter 3D environment, we have the ability to be able to do structural analysis, durability, additive manufacturing, materials analysis, motion, acoustics, dynamics, EMAG, thermal, and then multi-physics between those, and then, exploration, design exploration in particular. So that's a 10,000 foot level of what Simcenter 3D does. Let's look at the same thing on the Femap side. So Femap is our comprehensive mesh-based FEA. You heard me refer to Simcenter 3D as being geometry-based, and we'll explore that a little bit further as we go through the webinar. But Femap is really a traditional kind of mesh-based finite element modeling and analysis tool. So, if you're looking to replace for a good replacement for Patran or Hypermesh or ANSYS, excuse me, that has more features and more capability, then you're probably pointed in the right direction, looking at Femap. Or if you need to augment your existing FEA capabilities without disrupting your current workflow, and we'll see more about what I mean by that on our next slide here. But it can fit in seamlessly without much disruption. On the CAD side, or even on your solver side, you can continue to use the current tools that you're actually using, and augment that workflow by using Femap. And then there's a really big one that we see a lot in industry, and that is customers that have a need to reuse or modify legacy FEA models that don't have any underlying geometry. As engineers, sometimes we're a little bit lazy, and most FEA models start as a geometry-based model and move to a meshed finite element analysis model. And we're not always disciplined enough to be able to store all of that data. And that's what this whole digital thread is about, is being able to do a better job of that. But unfortunately, in the past, we do have a lot of what we see as orphaned FEA models out there that folks want to reuse or modify or change or use as part of an assembly moving forward. And so we need to be able to have tools that can handle that situation. And Femap does a good job of that. So like I said, if you look at Femap itself, it is a CAD independent and solver independent finite element analysis pre and post processor that uses a mesh centric type design to drive our workflow. It's got very comprehensive pre and post processing. We can, as we'll see, import geometry from just about anywhere, prepare that as a finite element model, create the mesh, and then all the boundary conditions and everything to fully define that model, and then solve it with a solver. And on the solver side, we are also solver independent. We hope that you're using Simcenter Nastran, but we're really kind of solver independent as well. We handle and interface with all of the industry standard solvers that are out there. And then we can look at the model results once that solve has been done. And we have a lot of workflow customization tools to allow you to tweak your process to make it more efficient for what you do through a great application programming interface that's built directly into Femap. So if we look at these two products, I'm going to contrast them a little bit. There are a lot of similarities, but there are also a lot of differences. So if we look at Simcenter 3D first over on the left-hand side of this chart, it is geometry-centric workflow by design. So, geometry is at the heart of that workflow, and everything really revolves around the geometry, and we'll see that as we move forward. And because of that, we have integrated our NX CAD geometry engine directly into Simcenter 3D. So you can create your CAD geometry and manipulate it there. But we have also integrated the finite element aspect of Simcenter 3D directly to the CAD and made it associative such that we can seamlessly connect the CAD geometry to the simulation models. And why is that important? Well, especially up front in early design, the geometry may be changing. It may not be stable over time. You may be looking at variations, and you don't want to have to go recreate your finite element model every time somebody tweaks the geometry a little bit. And so Simcenter 3D is a really good environment there, whereas if you change the geometry and the change is not too drastic, the finite element model will update and save you a lot of time in the process. Simcenter 3D does support multiple personas from designers to CAE discipline specialists. As I talked about before, there's a load of multiple disciplines in there, including motion, EMAG, acoustics, and others. And, it's kind of a all-encompassing multi-physics environment. If we look at Femap on the right-hand side, that tool is mesh-centric workflow by design, as contrast to a geometry-centric. So, we do deal with geometry in Femap, and we import geometry, and we can use that as the basis for our engineering models. But at the heart of it, we are a mesh-centric workflow, and I'll explain that on the next slide. And we are CAD agnostic. We can interface to any CAD system that's out there, just as easily. We hope you're using NX or Solid Edge, which are our tools. But if you're not, that's fine. We interface with the others just as well. But we do offer comprehensive pre and post processing tools for cleaning up the geometry, repairing it, idealizing it for a finite element mesh. Really advanced options for 1D, 2D, and 3D meshing and mesh creation. And this ability to reuse and modify legacy structural FEA models that don't have any underlying geometry is a big part of the workflow as well. We can generate reports, and we also have workflow customization, as I spoke about before. But there are a lot of things that we have in common. So both tools share the Parasolid kernel. That is something that Siemens owns, and so that makes it rather nice. We license that to other people and that use it in their software, but it's at the heart of both of these. So we share a geometry kernel. Both of these tools can be bundled with Simcenter Nastran. Of course, we can share results and models between the two products. They both integrate to our Teamcenter integration, which we'll see more about later on. They both are available in a desktop or enterprise licensing scheme. And we offer token licensing now, options for solver access from either one of these tools. So I hope that helps a little bit. If we start to look at where one might try to migrate to one tool versus the other, if you're familiar with CAD tools and CAD methodology, that is kind of the workflow that's inherent in Simcenter 3D. So that tool, may work a little bit better for you. If you're looking for design traceability by having one master model that contains both your CAD and your CAE data in one model, that's the way Simcenter 3D works. Of course, with Teamcenter, we can track and associate, a CAD model that is separate from a CAE model, but there is advantages to having both of those in one master model as well, especially if the geometry changes are a fluid part of the design. like I talked about before, this ability to be able to update your CAE model if the geometry gets tweaked. Like I said before, multi-physics, 1D to 3D co-simulation. On the other hand, if you're a simulation analyst that works kind of downstream of this preliminary design process, and you kind of take over once the design becomes fixed, then, and you're used to a traditional mesh-based FEA approach, you might be better suited to use Femap because that's the workflow that it uses. And especially if you're looking to replace Patran, Hypermesh, or ANSYS, which are also mesh-based workflows, then you might be a little bit more familiar in an interface that works in a similar manner with a mesh-based workflow. Again, if you have a requirement to use legacy models, I don't know of any other tool that's out there that can deal with the legacy models the way we can, and we'll explore that a little bit further here on the next slide. Those kind of, I hope that helps you contrast the two tools. They both offer design traceability and simulation data management. They both will allow you to customize your workflow. They both have customization tools built in them. They both perform structural analysis. And, if Nastran is your preferred solver, they both support Nastran. So, the desired solution that you end up with is often influenced by what your specific simulation requirements are and what your ideal workflow looks like due to your experience and maybe your use model. So if we look at Simcenter 3D, it is at the heart of a comprehensive digital twin. It does enable multidisciplinary simulation from a common model. It's got this integrated NXCAD engine in it, as I spoke to before. And by employing this in the correct way, especially during preliminary design and as the geometry is changing, you can really rapidly update your model a lot faster for more iterations and faster design of your products. So with Femap, I want to concentrate on what that workflow looks like in contrast to the Simcenter 3D workflow. So first off, let me say that, with Femap, we're CAD agnostic. We support all of the CAD systems that you see over there on the left, NX and Solid Edge being ours, and, our Ideas legacy product. But AutoCAD, all the iterations of Pro Engineer, CATIA, we can import, we can import through STEP or IGES. SolidWorks, we really don't care where your CAD geometry comes from. The process is the same. We bring it in. We have the tools to, clean it up and prepare it for meshing and go through that traditional finite element modeling approach, which is on the left, where you import the geometry, you do some amount of pre-processing, you send it to a solver, and then you post-process and look at results. But over on the left-hand side, I want to talk to a moment that we're also solver independent with Femap. So that means that we support Simcenter Nastran, MSC Nastran, Autodesk Nastran, Abacus, ANSYS, LS Dyna, and Adena equally as well. And all of these, they're not really even translators. They're part of the model environment itself. They're all built in. You don't have to buy them separately. They just come with the package, just like the CAD import capability comes. So there's nothing extra to buy, and they're all included. But we're seeing more and more of our customers, that are looking for a traditional mesh-based workflow. And, they've been FEA analysts maybe for a long time. They're used to that workflow. And one that is able to accommodate reusing these legacy finite element models. Let me explain a little bit more what I mean by that. So let's say that you've got a MSC Nastran model out there that was archived, and it's a finite element model, and it's got everything that's needed in order to run that finite element model in MSC Nastran. But now you want to repurpose that. So you want to be able to change the mesh, change the boundary conditions, change the material properties, integrate it into an assembly where you've got new geometry, maybe even. The Femap workflow is very good and has tools to be able to deal with that underlying mesh and modify it without having any underlying geometry associated with it. So it's kind of unique in that it was able to do that. So it would be possible to import an MSC Nastran model, repurpose it, and then write it out as a Simcenter Nastran model for existence. It would be able to take an Abacus model and import it and write it out, as an ANSYS model. If all things being equal, the solvers have different, some different features or whatever. And if features are common and the things they support are common, then we have people that are able to do that. So it's kind of like a Swiss Army knife when it comes to dealing with these different solvers. Or maybe you want to run an underlying Simcenter Nastran model and you have the need to do some complex nonlinear with Abacus. You can do that based on the same model within Femap. So I hope that helps. As you would expect, very comprehensive set of meshing tools for doing all of this, and then Teamcenter integration providing a managed workflow for that, as we'll see as we move forward. So we've got a lot of companies that use both products together too. I don't want it to sound like it's an either or, and this is just a small sample of the companies that use both, but there are a bunch of them out there, and there's more and more every day that use both. Just because the workflows within the companies are varied, and some people prefer one tool for one part of the design process and another tool for another. So, as Siemens, we started looking at this and we said, well, if we've got more and more customers that are using both of these together to enable an engineering digital thread, then why don't we bundle them together? So now we do. So we have a fairly new bundle. This has been out a little over a year now, but we have a product called Simcenter 3D Pre and Post and Femap bundle. And this is licensed a little bit differently than maybe what you've seen in the past, but this is a single license where a single instance of Simcenter 3D or a single instance of Simcenter Femap can be run at one time, but only one or the other at one time. So it's kind of like an either or switch. So if you have this license and today you want to use it as a Simcenter 3D license, you can use the full capabilities of Simcenter 3D. Maybe in the afternoon, somebody has a need to use that same license, but they're building a Femap model. Well, they can use that same license. So like I said, it gives you the ability to be able to run both of these products with one license. And it really is the equivalent of our 3D engineering desktop plus Femap in one license. Okay, so if you're going to use that, there are some bundle Nastran considerations that you have to keep in mind right now. First is that it's a SaaS only product, so we're not currently offering this as a perpetual product. So it's a SaaS only product. It does work with our Simcenter 3D value-based license tokens. So if you're familiar with our token systems, we enable a lot of different aspects of different solvers through our token systems. So you can get at all of the different features of, for instance, Simcenter Nastran, whether it's, our basic analysis, our dynamics, nonlinear, acoustics, any of the things that we offer, especially for Nastran, are covered under the token system. So a lot of people like to use that option. It also works with enterprise, what we call enterprise Simcenter Nastran licensing, or enterprise licensing, that is kind of our all-encompassing Simcenter licensing. And we're looking really quickly to offer another product which bundles Nastran as a core piece of this either or bundle as well. So in summary, over those two, if we look at the two products, like I said, one is an integrated geometry-based multidiscipline simulation environment that contains a lot of different things: motion, additive manufacturing, acoustics, advanced thermal, durability, EMAG. A lot of moving parts are available through that one interface. And especially if your geometry changes or a fluid part of your design, having this CAD associativity to the CAE model, where it can update as the CAD model is updated, is a big advantage. And that's something that's offered, through Simcenter 3D. If, on the other hand, you're looking for a comprehensive, mesh-based traditional FEA tool, or looking to maybe replace Patran or ANSYS or HyperMesh, or if you've been familiar with those tools in the past, then Patran is a very comprehensive, and we feel like has more capabilities than those other tools. And the beauty of it is, in the case of Patran, it's really written for MSC Nastran and nothing else, and ANSYS is written for ANSYS and nothing else. HyperMesh is a little more open than that, but having this multi-solver support built in, and support for all of the different CAD systems is at the heart of this open concept that we use for Femap. So, whether you're using MSC Nastran, Abacus, ANSYS, LS9, we have folks that tell us that, they actually prefer using our pre and post to run Abacus over, Abacus pre and post, just because we have more capabilities. So, I hope that helps. Femap is more simulation analyst driven. If you look at the personas of those folks that perform design and validation work downstream of the CAD model after it's frozen, these are the people that typically kind of migrate more towards maybe Femap than they do Simcenter 3D. But like I said, we have more and more folks that are using both of them and both of them together, within the same company. And so if we look at go back to our product design and engineering digital thread, and if we're going to use more than one tool, this becomes even more important that we be able to manage this process and manage the data that flows through this process. Like we've seen before, not only in these two areas that we looked at for mechanical design, but in all the areas that are in this digital thread. So we feel like that simulation data process and data management is the glue that really binds this whole digital thread together. And we need to have a way to be able to handle that. So, if we look at the typical unmanaged analysis environment that's out there, we've got an analyst sitting at the middle, and he's getting requests from designers and program managers on the different work that he's done. He's taking inputs in from product data and configuration data and materials data and requirements, and he's doing his or her thing. And then he is, creating simulations and applications that come out of that, and then managing the storage of all of those models and all that data and all of those results. Hopefully in some fashion where somebody can come back and, see what he's done later, or if something happens, he leaves the company, he or she leaves the company, that data is stored in a place where it can be reused. And even communicating with other analysts on what's going on different parts of these multidiscipline models. And what we found if we got there and poll different people is that, at least 30% of an analyst's time is spent seeking and providing information, and that another 32% was spent in discussions or meetings that was talking about what they have done or what they're about to do. And so, a lot of folks say that only 5% of analysts are managing their data in a way that would allow others to go find the results of these discussions without having to possibly even involve the analyst. And so that's what we're looking at for doing some really big gains in productivity. So if you look at a managed and streamlined analysis environment, we'd love to have an environment where the requests come in to one central place, and it's housing your simulation management data, your product data, your configuration data, simulation data, all your simulation tools, your simulation workflows, your requirements, and the schedules. And that folks have the ability to be able to query where these things are at any given time in a manner without having to reach directly out to individuals. So if you look at a simulation data process, management maturity pyramid, this is what we see with customers. So we often see that, we just have the wild west, I call it, where the data is kind of unmanaged. It's stored locally with no reuse, no PDM system, or if there is a PDM system, it's used for the CAD models only, and their simulation data is unmanaged. And then we run into quite a few companies who have at least taken the first step, and they're archiving their data like in blobs with limited traceability and very little reuse, but the manual import and export of CAD and CAD data is being used to interface to the database. At least it's being housed in one central location, but their simulation processes are still unmanaged. And then we see step 3, where we do have data seamlessly captured and managed in the background. So as part of your day, what you're doing is being captured and automatically put into the database as your models change. And that's at least a good jumping off place of where to be. But past that, companies are moving to better maturity where they're looking at process management and even process automation based on the data that's stored too. So, what we try to do is to get companies to at least be at the 3rd level, where they're managing their simulation data, keeping it organized and managed. The key simulation applications are integrated where they're capturing and reusing that data as they move forward. So the tool that we use at Siemens in order to make that happen is called Teamcenter, and it is a simulation process and data management tool that allows engineers and CA analysts to speed up their simulation and make better effective decisions, and to be able to answer these questions that come in a lot more seamlessly. So there are a lot of different parts that we can support in simulation data process management. We're just real quickly going to highlight a couple, and we're going to talk about our simulation data architecture. That's kind of at the heart of what we do. Our simulation data model does allow for capturing everything from the engineering proposal and the initial design, where you got frozen master CAD data, a CAD part or an assembly, and how the analysis geometry that's going to be used is tied to that. Many times this geometry is idealized, defeatured, or mid-surfaced in order to create a finite element model, but it is important to know how it relates back to that original CAD model. And then from there, we create analysis models. These are meshed models that have materials associated with them, or possibly different sections of the model are analyzed. And then we have those run-ready model decks that we create that include the boundary conditions, the whole input deck to whatever solver we're using, and probably even the raw results that are the process that after you run that simulation model, the results that come back. And then we need to have the ability to be able to store actionable insight, which is looking at the CAE results in ways that engineers like to look at them, which is shared results or reports or images or animations that, that shows what are going on in the model and whether or not the model, is fit for the application that it was designed for. So all of those things are supported in our simulation data model with, the bonus of being automatically identified or messaged when something goes out of date. So let's say that, some piece of what you've used within your model all of a sudden has been changed. You need to know that. If there are upstream dependencies that are designed changed, or the requirements changed, or the parameters changed, you're automatically notified that, what part is out of status and for what reason, so that you can go take the appropriate action. So, that's important. Just the visualization of your simulation data, a place to house all of the results in a interactable format. We use a lightweight JT format, which is an ISO standard for looking at quick visualization, and we're able to store any manner of the results data that you might want to look at. So we can look at geometry, assemblies, the meshed models, the load cases, the input decks, all of this stuff embedded in a browser mode in a viewer, a real lightweight viewer where you can get in there and interrogate and find the information that you need for your purposes. And then the structured management. Obviously, the tool is going to be more effective if it's structured, and Teamcenter supports, of course, the full design assembly in a structured manner where you have a master part and all the sub-assemblies. But that is also tied to the analysis assembly. So you can tell what geometry was the source of the analysis assembly that came out of that geometry in a very structured way, what all the different iterations are, which iteration is current, and then look at your analysis setup that's defined based on that. What is the analysis setup? How was it done? What were the assumptions that were made there? And then what are the results? And, look and be able to tell that specific analysis results are tied to a specific analysis setup of that model and have full traceability back to the design assembly. And then also any related analysis that's done. Maybe there's an adjunct analysis. You've done the mechanical analysis, but somebody else has done a thermal or fluids analysis on the same part. And how are they related under the same analysis setup, especially as we move to more multidiscipline type integrated solutions. So, and then there's process automation. If your tool is not able to fit in an automated way into your environment, then it's probably not going to be very useful. And with Teamcenter, we allow to integrate external simulation applications, in-house tools, commercial tools, to your different computational managers that are out there that says, where your simulations may want to run and be able to launch those. But once that you have, entered something like Simcenter 3D or Femap in this managed environment, basically it's seamlessly behind the scenes, tracking, the data that you've created, the models that you've opened, and doing a lot of this associative work for you, behind the scenes without you having to really do much to intervene other than just set up the dependencies. We have fully integrated materials management that's in that. So you have one source of truth for your material models that are being used. And as we move forward with, more and more exotic materials, exotic coatings, and composite materials, this gets more and more important that you have one source of truth for where your materials came from and which materials data that you're using throughout the whole process. And so, to have a truly enabled digital thread, it needs to be able to encompass the analysis, the requirements, the logical models that are being used, all the parameters that are driving those, as well as the information that comes out of product design, and even downstream in the manufacturing operations. And so, that's what we're looking to create here at Siemens. And that's what, in our minds is a fully enabled digital thread concept. And so we kind of have to look at those together as you look at this whole thing. So I hope that makes sense. We've got a few minutes here for questions and answers. I don't know if any have come in the chat or not, but I hope that gives you information now that answers that burning question of, what's the difference between Simcenter 3D and Femap? Where are they used? How are they used together? And how are they used in a managed environment?
Thank you, John. We have a few questions in the chat, and Scott, I am going to unmute you so that I can ask him directly.
Hello.
Hey, Scott, can you?
Yep, we hear you.
You can hear me? Okay. So on the slide, John, where you were showing the kind of Venn diagram between Simcenter 3D and Femap, some of the things on the Femap side, like particularly being able to consume meshes that you're perhaps getting from your customer or your supplier or whatever, and you have no underlying CAD, that's perfectly understandable. But some of these things like modeling results visualization, reusing models, custom report generation, workflow customizations. Aren't those things also true of Simcenter 3D as well?
Model and results visualization, absolutely. I mean, that's built into any pre and post processor. But with I guess perhaps what we meant there is probably the results visualization that one is able to do in Femap is a little bit more extensive than what we can do in Simcenter 3D. For instance, we have this thing called a data table that's built into Femap that acts much like an Excel spreadsheet built in. So, you can take your results and you can put them in a table and you can manipulate them like you would do in an external environment in a data table to get more insight into them. We have just more advanced post-processing techniques that are available in Femap, just the way that product has matured over time. So it's not that you can't do model and results visualization in Simcenter 3D. You certainly can. It's just that probably those capabilities are a little bit more extensive in Femap. And this ability to be able to reuse and modify legacy models, that's something that's really unique to Femap, because you think about it for a minute. If you've got a geometry-based tool where geometry is master and everything relates to that, it kind of breaks your data model if you bring in just a finite element model. And in order to make that work, you would have to go back and recreate some geometry on that mesh in order to have a basis to be able to kind of complete that workflow. And some of those things are available in Simcenter 3D. They're just probably a little bit more difficult to use in that way. Whereas with Femap, we've created tools that are based on a mesh-based workflow where you can just go in and start manipulating the mesh in a lot of different ways and remeshing. A lot of different remeshing techniques, a lot of local, refinement or unrefinement of the mesh, those type of things that are all able to be done without any geometry at all. And so, usually if you're going to be trying to do those things, I would say Femap is probably the better place to do that. So does that help?
Absolutely. Absolutely. So you could, if you only had Simcenter 3D, you could bring in, meshes, but it would be more difficult to combine them with CAD-based models that you're making in Simcenter 3D. And it's just, you're kind of pounding screws with a hammer to a certain extent.
Yeah, that's correct. You can bring in the data and you can look at it and you can see what was done before. But, if you were to try to remesh that, like I said before, you'd have to somehow create some geometry based on that mesh. And there are some tools in Simcenter 3D to do that. You can skim the mesh with a geometry surface and then associate that surface back to the mesh. It's just extra work that is required to do that. And it's based on the fact that it's a geometry-based system, right? And so at the heart of that workflow, you do apply boundary conditions and all that type of things on the geometry. Whereas in Femap, you can apply them on the geometry initially, but they do get associated directly to the mesh, and then that associativity is retained, even if it is, becomes a legacy finite element model at that point.
Gotcha. On the data management side, are there certain aspects, if you were in a Siemens only environment, so you're already using Simcenter 3D and or Femap and Nastran, maybe other Siemens tools as well, are there ways of using regular stock Teamcenter without the Teamcenter simulation and product data management add-on that you can manage data, store data, recover data with just regular Teamcenter?
Yes, that is possible. What we call the product, TC for Sim is kind of a subset of the Teamcenter full up model that is been created just to manage the simulation data. But if you've got full-blown Teamcenter. Both Simcenter 3D and Femap are able to completely interface with Teamcenter, whether it's TC for Sim or full up Teamcenter, to be able to manage and control all that data.
Terrific. And I have heard that TC Sim has got an even better sort of value to customers if they're in a heterogeneous environment. So that, larger companies are not going to be 100% Siemens. They might have ANSYS, they might have various government codes or whatever. And my understanding is that that's a great environment for that TC Sim product. Is that right?
Yes, I'll refer back to this slide that's on. Yeah, I hope you can still see my slides. But the slide that I showed, we're talking about seamless integration of the simulation tools. This shows that you can have, any manner of even our competing commercial tools or your homegrown tools, any of that stuff in a Teamcenter environment, be able to launch those and capture the data just like we do with our Siemens tools, and be able to interface them in a managed environment way. Yes.
Terrific. And my last question is on the integrated material management. Is that part of TC Sim, or is that a separate module for Teamcenter?
You know what? I am not absolutely sure. I'll have to find that out and get back to you. I know it's a capability within Teamcenter, but exactly where it resides, I'm not familiar enough with that one to be able to answer that at this point in time. So you're talking about this slide. So I will find that out, and we'll get back to you on that.
Terrific. Thank you.
Any other questions?
Yes, one more. So there's a question: is there any way to associatively update geometry in Femap? There's an update existing geometry button, but not being able to find any documentations or make it work as they expected.
Okay, yeah. Let me answer that. So over time, especially in the last few releases, like I said before, we share a common data model. A common geometry engine in Parasolids, and as more and more features are added to Parasolids proper, we're able to take advantage of those, in Femap, because they just kind of come along for the ride. And one of the things that we've been putting in the last few releases of Femap is the ability to be able to, in some ways tweak geometry, and especially geometry that's already been meshed, and have the mesh just automatically update. Or let's say you've meshed two surfaces that don't exactly meet because of errors in the geometry translation. And when you zoom in, they don't share a common corner. We have tools that operate on that underlying geometry, where you can pick one edge and pick the other edge and say, align these together with a lot of different options to do that. And the mesh will update. And so we have more and more tools to where I would say it's more like making small modifications to the geometry and tweaking the geometry in a way that you often have to do, when that geometry is coming from a foreign, I'll call it a foreign CAD system. So there are tools that are built into Femap to do that. It's just within Femap, we don't have, the built-in CAD engine that is NX built in. What we have is the Parasolids kernel that we're operating on. So the approach is a little different. In the Simcenter 3D workflow, you can create all of your geometry right there, using a CAD-based tool like you're used to in a CAD environment, and it's a full-up CAD system. The geometry creation tools in Femap are rather primitive because that's not what it was designed to do. It was designed primarily to work on geometry that's coming in from some other source, and then cleaning up, changing, and manipulating that to get that ready for being meshed. So once again, kind of two different workflows. The mesh is at the heart of the workflow in Femap, and the geometry is at the heart of the workflow in SimCenter 3D. So I hope that answered your question.
Yep. And then you was asking, so can you kind of elaborate what the update existing geometry button in Femap does?
I'd have to see that in context of what in particular you're trying to do. I think probably that's answered maybe in a more in-depth demonstration where we could show, you know, some of those features to you that you could understand them a little more. It's a little hard to explain that concept without actually seeing it in action. So, you know, if you want to contact the folks at ATA, we'll get your name and we can set up a separate session with you where we can show you how that works and fully explain that to you.
Yep. Sounds good.
Because, you know, there are a lot of tools that are built in that are used in conjunction with each other. That button that you're talking about is just one of many tools that, you know, that are all aimed kind of at that same principle. Any other questions?
The other question I have is, has a webinar been done that compares the pre-post processing setup differences between SimCenter 3D and Femap using an example model?
Not that I know of. That might be a good one for a future webinar. But you know, I don't think we've ever set up a webinar just to analyze that in particular. That might be a good thing for us to do here moving forward. Good suggestion.
Yep, we might be able to do that in the future. Cool. I think we're over the set time.
Okay.
So we'll conclude the webinar here. Thank you guys for joining, and thank you again, John, for this wonderful presentation.
Sure. And if you have any questions that you didn't feel comfortable asking here or whatever, please reach out to ATA. And, you know, and/or myself, and we'll be able to help you. And we can discuss whatever it is that you want to get into. So we appreciate your time. Thank you very much for attending, and we'll see you the next time.
Thank you. Thank you, guys.